Hello everyone. Now we are going to see the first chapter of this M3, that is in our syllabus. There are total 6 chapters are there. Okay, and Laplace transform is the first chapter of Engineering Mathematics 3 syllabus. Now consider the introduction. First of all, we have to see definition of the Laplace transform. Let f of t, this is a function like f of x, let f of t be the function defined for all positive values of t. This for all positive values of t. We are defining one function f of t. Then Laplace transform of this function f of t, like derivative and integration, Laplace is again a function, right? Like derivatives and integration, there are formulas, rules for derivatives are there. Likewise, Laplace transform is a function, and Laplace transform have a particular definition, and there are some formulas, and depend on that formulas examples are there, and properties are there. Now let us consider the definition, where f of t is the any function defined on the variable parameter t, and then Laplace transform of such function f of t is denoted by L of f of t. L stands for Laplace, and f of t is the function, or phi of s. Why it is called phi of s, we are going to see further. And it is defined as L of ft is equal to, it is the basic integration. The limits of the integration are 0 to infinity. Integration 0 to infinity e raised to minus est ft dt. Okay, whatever the function is, we have to take the integration along with this, multiply by e raised to minus est. Okay, if we solve this integration and put, after solving the integration, we put the upper and lower limit in t. That's why the ultimate answer for this integration comes in the form of s. That's why it is also function of s. That's why it is also called phi of s. In some properties, we are using this phi of s notation. Okay, and provided that integration be exist. Here s is a parameter. Here s is the parameter in this integration, which is real or both complex. The symbol L is usually called Laplace transform operator. This L is called Laplace transform operator, like d by dx is the derivative operator, right? It is the integration operator, integration sign, derivative operator. Del is also there, we have studied del also. Likewise, L is called Laplace transform operator. This is the basic definition of Laplace transform. In exam, they can ask the definition for 1 or 2 marks. Okay. Now, like derivatives, after derivative definition, we have studied the formulas, basic formulas. Likewise, Laplace, after definition, we have basic formulae for Laplace transform. Now, number 1, there are total 7 formulae only. On the basis of these 7 formulae only, we have to study the whole Laplace first chapter and second also, that is inverse Laplace transform, inverse of this transform. If Laplace, we know all the formula for Laplace, we can easily go through or we can easily solve the inverse Laplace transform examples also. Okay, now first, Laplace of 1 is the number 1, Laplace of 1 is 1 by s. These are the formulae you have to mug up only. Okay, there is no any proof for this formula, you have to just mug up all these 7 only. 7 formulas are there. L of 1, that is Laplace of 1 is equal to 1 by s. 1's Laplace is 1 by s. E raised to at Laplace is 1 upon s minus a. You have to minus this number. A is it is exponential. Exponential e raised to at. A is the any number. It may be positive or it may be negative. If positive number is there, you have to subtract from s. If negative number is there, you have to add this number to s. That is e raised to at Laplace is 1 upon s minus a. E raised to minus at Laplace is 1 upon s plus a. Now third formula for sine, and next one is for cos. Sine at, Laplace of sine at is a upon, what is this a? The angle, the number attached to the t here in the angle. a upon a square plus this number square, a square. Whatever the number, and you have to square this number, a square. Now cos at Laplace is just replace a by s here. Wherever cos is there, numerator is s upon denominator is same for sine and cos also. That is s square plus this number square. Okay, sin at Laplace is a upon s square plus a square. Cos at Laplace is s upon s square plus a square. Now hyperbolic functions, two hyperbolic functions. H is sign for hyperbolic function. It has particular formulae we are going to see in the examples. Sine hyperbolic at Laplace is just replace this plus by minus sign here. Rest everything terms are same. Just replace here plus by minus sign. Whenever hyperbolic function is there, just replace plus by minus sign. A upon sign is there, that's why a upon this a number, that is a coefficient of t in the angle, s square minus a square. Likewise cos hyperbolic at Laplace is just replace plus by minus sign here, right? S upon s square minus a square. These are 6 formulae. Now last one, t raised to n. N is the any number, positive number. That's why t raised to n, there are 2 formulae basically, where first one is n factorial upon t raised to n. Laplace is, Laplace of t raised to n is n factorial. There is a factorial function which is present on your calculator also. N factorial upon s raised to this number plus 1. Just add plus 1 to this number, above number here. Okay, nice number. And this is the formula when n is positive number or positive integer. If n is fraction, then there is other formula for this, because we cannot calculate the factorial of the fraction numbers. Okay, if you put the value of half factorial in the calculator, you will get the mathematical error. Okay, that's why for fraction there is other formula for Laplace of t raised to n, that is gamma. This is the term gamma. What is the gamma? We are going to see in the example. That is gamma function. It is same like root. Okay, it seems like root only. N plus 1 upon denominator is same, s raised to n plus 1. Okay, now consider this, the meaning of this gamma. Now these are some notes. Number 1, 0 factorial or 1 factorial value is same, that is 1. Gamma n formula, first formula is n minus 1, whatever the number it is, just put minus sign, minus 1, just subtract 1 from this number and take the factorial of this number, that is n minus 1 factorial. For example, 1 factorial is 1 minus 1, that is factorial, that is 0 factorial. What we know, 0 factorial is 1. Gamma 3, for example, second example, 3 minus 1, n value is 3 here, factorial. What is 3 minus 1? 2 factorial. 2 factorial is 2 into 1, that is 2. 4 factorial, that is 4 minus 1 factorial. 4 minus 1 is 3. Again 3 factorial is 3 into 2 into 1, that is comes to 6. That factorial term you can calculate from calculator also. Okay, for largest number you can use you should use calculator. Now again second definition for gamma, if fraction number is there, in some examples we have to calculate the gamma numbers or gamma values. Gamma n, other definition is n minus 1 into again gamma n minus 1. Just subtract 1 from this number and put this number again in the gamma function. For example, gamma half is the basic gamma number whose value is root pi. Okay, remember this, gamma half wherever comes we have to put a root pi in the example. Okay, gamma minus half is nothing but minus 2 root pi. You have to again mug up all these two basic numbers. Gamma of half is root pi, gamma of minus half is minus 2 root pi. Okay, now next come to gamma 3 by 2. To put this value here, n is equal to 3 by 2, here we get 3 by 2 minus 1, and gamma 3 by 2, same number, 3 by 2 minus 1. What is 3 by 2? Again half. Gamma again half. What is gamma half? We know it is root pi. Okay, therefore value of wherever in the example last if we have last solution is gamma 3 by 2, we have to solve this up to this. half root pi. Okay, well, like next example, gamma 5 by 2. Again subtract 1, put n is equal to 5 by 2 here, subtract 1 from 5 by 2, we get 3 by 2, and put this value again in gamma 3 by 2. And what is gamma 3 by 2? In early example we have solved this, half root pi, right? Now ultimately what is 5, if denominator is 2, okay, we have to solve this gamma like this. Otherwise in rest of the denominators you can keep that value as it is. Okay, 5 by 2 becomes 3 by 2, subtract 1 from 5 by 2, we get 3 by 2, again subtract 1 from 3 by 2, we get 1 by 2. You have to go on subtracting 1 until you get half at the end. Okay, and put the root pi in after 1 by 2. Okay, now gamma 7 by 2, subtracts 1 from 7 by 2, that is 5 by 2, again subtract 1, 3 by 2, again subtract 1, that is 1 by 2, and last is root pi. Like 9 by 2, gamma 9 by 2 is, subtract 1 from 9 by 2, we get 7 by 2, into again subtract 1, that is 5 by 2, again subtract 1, that is 3 by 2, again subtract 1 by 1, that is 1 by 2, and stop here by putting again last number root pi. This is called the gamma function. Okay, now fourth note, these are some formulas. We have already studied all these formulas, just you have to recall all this, you have to mug up all these formulas. First one is sine hyperbolic t. This is a hyperbolic function definition. Basic two hyperbolic functions we are going to use, that is sine hyperbolic t is equal to e raised to this number t, whatever it is, t2, t3, t, you have to put this angle to the exponential, index to the exponential, e raised to t, minus, for sine minus is there, for cos plus is there, e raised to minus t, opposite angle, divided by 2. For cos, e raised to t plus e raised to minus t upon, that is divided by 2. These are double angle formulae. 2 sin a cos b is sin a plus b plus sin a minus b. 2 cos b is cos a plus b plus cos a minus b. 2 sin a sin b is cos a minus b. Just up subtract, just reverse this above 2 for this third one, and put plus, instead of plus put this minus. Okay, in examples 2 is supposed to not in the given in the example, you have to take 2 on that side, 2 half. Okay, sine of minus theta or sine of minus angle is nothing but just take minus outside of this angle of sine, that is minus sine a, and cos of minus a is nothing but a negative sign absorbed by cos, because it is a even function and sine is an odd function, that's why for sine minus gets outside. Cos of minus a is cos a. This is a Pascal triangle, we have already studied. It is a short key to expand any power of two addition of two terms, two expressions, right? We have to first prepare this triangle. The edges of all this triangle are all number 1. This is number 1. Below that second row is 1, 2, 1, and go on adding these two numbers and put that number to the in between these two number below that row. What do 2 plus 1 is 3, 2 plus 1 is 3, again last edges are obviously 1. Triangle we have to expand the edges. Okay, now again this is 1, 3 plus 1 4, 3 plus 3 6, 3 plus 1 4, and last one is 1. Again go on adding those numbers, 4 plus 1 5, 6 plus 4 10, 6 plus 4 10 again, and 4 plus 1 5, and last one is again 1. Here again 1, 5 plus 1 6, 10 plus 5 is 15, 10 plus 10 is 20, 10 plus 5 is again 15, and 5 plus 1 is 6, and last one is 1. Okay, you can go on expanding this triangle. This is called Pascal triangle. Now how it works, This is the second row is a coefficient of a plus b bracket square. 1 2 1. A plus bracket square, we know a square plus 2ab plus b square. Okay. Now for expanding the bracket, we use one binomial theorem. What that binomial theorem says, just go on decreasing the power of first number and start with that same index, that is a square, then go on decreasing power till a raised to 0, that is square, then a raised to 1, a raised to 0, and anything raised to 0 is 1, that's why we never write it here. And go on increasing the indice for or power for second number. Here b start from the power 0, b raised to 0, that is 1, plus b raised to 1 and b square. Same rule apply for any power. Just a plus b bracket just to any number. We can follow this binomial rule. Here a plus b bracket cube is nothing but a cube plus 3a square b plus 3ab square plus b cube. Now again a power get decreased from a cube, a square, a raised to 0. B power get increased by b raised to 0, b raised to 1, b square and b cube. And where these coefficients come from this triangle. Okay, we can expand this by using binomial theorem, but we cannot have logic behind these numbers. Okay, these numbers you have to take from this triangle. Like second row of this triangle is for a plus b square bracket square. Okay, this 1 2 1 after writing this all binomial expansion. And a cube, third row is for a plus b bracket cube, that is 1 3 3 1, 1 3 and 3 1. Okay, likewise the a plus b raised to 4 is nothing but just write down a power of a in the decreasing manner, that is a raised to 4, a cube, a square, a and a raised to 0, and go on increasing the power of b, that is b raised to 0, b, b square, b cube and b raised to 4. And this coefficient we have to take it from this fourth row of this Pascal triangle. Okay, that is 1 4 6 4 1, 1 4 6 4 1. Like this you can expand any power of a plus b bracket raised to any power using this triangle easily. This is a shortcut to expand any power. Okay, now next formula is sine square x or sine square theta or sine square. Here we throughout the Laplace we are using parameter t or variable t, that's why in the all formulae we are using t only. Okay, sine square might be you have mug up by sine square theta or sine square x something. Okay, sine square t is nothing but 1 minus cos 2t upon t, and same formula is applied for cos square t, just replace minus by plus. Here also for sine, wherever sine is there, one negative sign is there in almost every formula. Okay, cos hyperbolic positive sign is there. Here also for cos square 1 plus is there, for sine square 1 minus. Okay, now this is the again sine cube formula. This is 1 by 4 3 sin t minus sin 3t, cos cube is 1 by 4. Just twist that term, instead of this sine we write it as cos 3t and minus replaced by plus 3 cos t. Okay, sin a plus minus b. In a Pascal triangle, if we have to take minus sign here, just replace plus minus plus alternating, go on putting alternative plus minus sign. If minus is there, plus minus plus. Here if minus is there, plus minus plus minus, like this. Okay, for sin a plus b, sin a cos b plus cos a sin b. Similarly for minus, sin a minus b, sin a cos b minus cos a sin b. Cos a plus b is cos a cos b minus sin a sin b, and cos a minus b is cos a cos b, just opposite to the sign, plus sin a sin b. Okay, and this is one more Laplace property. Laplace property is Laplace follows almost every property, linearity property of derivative itself. Okay, like Laplace of a plus b, where a and b are for convenience. I instead of putting f1t f2t, I put here a and b, where generally we use a and b as a constants. Okay, I mention here a and b are for convenience functions of t. Then Laplace of a plus b is nothing but Laplace of a plus Laplace of b. It follows the linearity property. And if minus is there, here also just put minus. Okay, now a plus b into a minus b, this is the basic formula, that is a square minus b square. Okay, now we are going to see the basic examples for Laplace. Find Laplace. Question is, as it is, very straightforward. Find Laplace transform of the following functions. There are some basic, I have taken some basic. These are not that much of simple. Are going to ask in the exam. Now Laplace of 1, it is a 1 by s. Laplace of e raised to 2t, where is we have to just calculate those answer by using the formula, basic formula, where we have we should mug up here. What is e raised to 2t is second formula, e raised to at. Okay, what is a here? 2. Okay, that's why the answer for Laplace of e raised to 2t is 1 upon s minus 2. Similarly, if Laplace of e raised to minus 4t, just if minus is there, we have to reverse this sign, plus 1 upon s plus this number 4. What is Laplace of sine 2t? Sine at, a upon s square plus a square, this number square. 2 upon a square plus 2 square, you can write directly 4. Okay, instead of 2 square, you can directly, everywhere in the examples, write 4. Cos 3t, that is cos 80, Laplace is s upon s square plus a square. Just remember, cos ends with s, that's why in the numerator s is there. Okay, it is just for your convenience. S upon s square plus this number square, 3 square is 9. Sine hyperbolic 2t. What is sine hyperbolic 2t and sine 80? Difference between Laplace is just denominator have plus and minus sign. Okay, that's why sine hyperbolic 2t like this. It is 2 upon s square minus this number square, 4. Cos hyperbolic 4t is s upon cos, wherever cos is there, numerator is s, upon s square, this minus, because hyperbolic is there, minus 4 square is 16. These are some basic formulas derived from this only. Okay, now consider some more complicated, where we have to use these all formulas. Okay, first, Laplace of sine t into cos 2t. See, if multiplication of two trigonometry is there, if square of something is there, wherever trigonometry comes or any complicated formula comes, we have to use the basic mathematical formula to convert those entities into simple ones in our 7 formulas only. Okay, like for example, here sine into cos is there, but we don't have any sine cos formula here. We have only sine formula or cos or hyperbolic or cos hyperbolic, right? That's why we have to use here formula, basic mathematical formula. Where is that? Sine a cos b here, right? You have to mug up all this formula. Okay, 2 sine a cos b is nothing but sine a plus b plus sine a minus b. Okay, like that. Sine a is nothing but angle t, and b is nothing but 2t. That's why it is L Laplace is same. Just to carry forward same Laplace until and unless we reduce this formula into basic formulas. Half, we should remember this 2, because everywhere, almost in all examples, this 2 is not there. Okay, 2 is not given. We have to take this 2 on that side by half. Okay, now take half on this side, and sine a plus b, that is t plus 2t. Okay, addition of two angles, plus sine a minus b, that t minus 2t. Okay, now add these two angles, because we can add to same parameters. T plus 2t is 3t. The rest of the terms as it is, t minus 2t is minus t. Okay, now we know what is sine of minus theta? What is sine of minus a? Minus sine a. Minus comes outside. That's why it becomes minus here. Rest of the term as it is. Now take Laplace inside to each term. Laplace of sine 3t minus Laplace of again sine t. Okay, now half again. What is Laplace of sine t? Now it becomes the it comes in our natural 7 formula. Now apply the 7 formula here wherever it fits. Now it is sine Laplace is 3 upon s square plus 3 square minus as it is sine, again sine is there 1, here no coefficient is there, that's why it is 1. Okay, nothing is there, obviously 1 is there, 1 upon s square plus 1. This is our answer. Now depend on the this term we have to simplify. Okay, these are the short terms, we can simplify. Just cross multiply. Okay, 3s square plus 3 into 1 3, it is minus term, that's why these two terms gets minus. Okay, s square minus 9, 3s square minus s square 2s square, 3 minus 9, that's minus 6. Now again 2 from numerator 2 gets common and cancel with this 2. Answer becomes, or answer is s square minus here 3 and denominator is same. Okay, now like this sine cos is there in exam, they can ask for sine cos, cos cos, sine sine. Nothing is different from this three formula. We have only 3 formula for multiplication of trigonometry. Okay, now second we are going to see for cos cos. Okay, this formula 2 cos a cos b, we have to now use this second formula for this. Okay, now a is 2t, b is 4t. Half you have to in the example, in the formula only 2 is not there, that's why you have to take 2 on this side everywhere. 1 by 2, that is half. Laplace as it is. Again like derivative, like integration, whenever constants are there you can take it outside from the Laplace. Okay, half Laplace of cos a cos b is cos a plus b plus cos a minus b. Okay, a plus b, that is 60, plus cos a minus b, the minus 2t, 2t minus 14, that is minus 2t. Again we know cos of minus theta or minus a is plus cos theta. Okay, that's why it becomes cos 2t only, and take Laplace inside. Okay, we get cos 60 Laplace s upon rest of the term as it is 6 s upon s square plus 6 square, that is 36, plus cos 2t Laplace is s upon s square plus this 2 square is 4. Okay, now simplify like above. This cross multiply. Okay, s cube plus 4s plus, again this is addition only, no need to change any sign, s square s cube plus 36s. Okay, now add above this s cube plus s cube to s cube, and 36 plus 4, that is 14. Denominator is same. Okay, now half 2s cube plus 40s, take 2 common and cancel from the take 2 common from the numerator and cancel with this outside half. We get final answer s cube plus 20s upon denominator. These two terms are same. Okay, this is cos we have just solved. Now last one is sine sine, the third example. Now again use the formula sine a sine b, like this. Third one, 2 sine a sine b is cos a minus b minus cos a plus b. Just take 2 on this side, we get half Laplace of cos a minus b t minus 3t minus cos 3 plus t plus 3t. T minus 3t is minus 2t, minus as it is, rest of the term as it is, cos 3t plus t is 4t. Okay, now again cos of minus theta is plus cos theta, cos 2t, and take Laplace on inside to each cos. We get cos 2t Laplace is s upon s square plus 2 square minus sine cos, again Laplace of cos is s upon s square plus this 4 square 60. Okay, now simplify, just cross multiply, and s cube gets cancelled. 16s minus 4s is 12s. Okay, then just cancel this 2 with this, we get 6s upon this denominator as it is. Okay, these are some formulas, examples. Now another, they can combine three terms like cos, cos, cos. Okay, consider this example where three trigonometries are there. The way of solving this example is very simple. Just make two term combine here, any two. You can combine cos 2t into cos 3t also. Here take first lowest angle, it is convenient for convenience, cos cos here first, and keep this cos 3t as it is and apply cos cos formula here. Okay, which is that half cos a plus b plus cos a minus b for these two only, because these are two, all are in multiplication. Okay, now solve this. T plus 3t, rest of the term as it is 3t, t minus 2t, again minus t for cos, minus doesn't matter, cos t. Okay, soon after, if we practice all these things, we can skip some so simple steps also. Okay, this cos t. Now this is half, take outside, Laplace is as it is. Okay, until and until we get separate cos sine, we cannot use, or we cannot take Laplace inside. Okay, now what happened, half gets outside and multiply this cos inside with each term. Okay, what we get, cos 3t, cos 3t, cos square 3t plus cos t into cos 3t. Now again we have to apply the separate formula for these two terms, where cos square we have formula 1 plus cos 2t. If t is there in formula, 2t, double angle is there. Therefore cos square 3t becomes 1 plus cos 3 into 2, 60 upon 2. This is the formula for this cos cube, cos square. Plus again apply cos cos formula like above, like here we have just used. That is half here, this half is in the bracket only. Cos a plus b plus cos a minus b. Okay, now this as it is. Okay, plus half as it is, 3t plus t is 4t, t minus 3t is minus 2t, for cos minus doesn't matter, cos 2t. Okay, now this is the bracket. Now apply Laplace inside, take 1 by half, 1 by half outside, we get 1 by 4 here, and in the bracket we get 1 plus cos 60 plus this bracket. Okay, no need to keep the bracket now apply Laplace inside. Laplace of 1 is 1 by 6 plus Laplace of cos s upon s square plus 36 plus Laplace of cos 4t s upon s square plus 4 square plus cos Laplace s upon s square plus 2 square is 4. This is the answer. Okay, where more than two terms are there, you don't need to cross multiply this thing. Okay, if s square terms are there, biggest terms. Okay, this is the cos 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 terms example. Now it is the homework, which is the first homework, that is sine t, sine 2t, sine 3, like this only you have to solve this. Just apply sine formula here. Okay, now next example, Laplace of sine cube. Okay, sine cube, we are going to see now cubic trigonometry, that is sine and cos cube also. Sine cube formula we know, it is 1 by 4 3 sine t minus sine 3t. Okay, if t is there, formula here also t. If t is there, here 3t. Okay, 3 times, angle becomes 3 times. Okay, here 2t is there, that's why formula becomes 1 by 4 as it is, 3 as it is, sine same angle, that is 2t, minus sine triple of this angle, that is 3 into 2, that is 60. Okay, you have to apply this formula like this. Now this is the simplest, becomes simplest one. Now apply 1 by 4, it is a constant, take outside, Laplace apply to each term, Laplace of 3 sine 2t minus Laplace of sine 60. Take, this is again a 3 into, that's why 3 comes outside from this Laplace only, not from this bracket. Okay, 3 Laplace of sine 2t minus Laplace of sine 6t. Okay, 3 as it is. Laplace of sine 2t is nothing but, this is the standard formula, 2 upon s square plus this 2 square minus sine again Laplace 6 upon s square plus 6 square is 36. Okay, again 3 into 2 is 6. Here also 6, take outside, 6 by 4 and 1 upon s square plus 4 minus 1 upon s square plus 30. These are the two simple terms, that's why cross multiply. We get this denominator multiply with this, the multiplication of these two terms. Okay, s square gets cancelled, 36 minus 4 is 32 and simplify these two, we get 42. For answer is 48 upon this s square plus 4 into s square plus 36. Okay, this is cubic trigonometry. Sine, in exam we are going to ask only sine or cos only. Okay, now this is the second homework, that is cos cube instead of sine cube. You have to solve this cos cube t Laplace using cos cube trigonometry formula. Okay, now 15th example, Laplace of sine hyperbolic. The h means hyperbolic function. Don't say h, it is hyperbolic function. Sine hyperbolic 2t, its cube. Okay, whenever in any example hyperbolic function comes, you have to put the formula for hyperbolic function. What are those formula? We have already studied here. This one. Okay, wherever in any example, if hyperbolic function comes, you have to put this formula. Okay, now what is sine hyperbolic? E raised to t minus e raised to minus t divided by 2. For cos hyperbolic, just replace minus by plus sign. Okay, like this. Sine hyperbolic 2t is nothing but e raised to 2t minus, for sine minus sign is there in the formula, e raised to minus 2t upon 2 and cube, its cube. Okay, and square bracket complete. We have to find out this Laplace. Again take 1 by 2 cube, that is number constant in any step, at any step, whenever constants involve, we have to just take it outside. Okay, 1 by 2 cube take outside, 1 by 8 Laplace of e raised to 2t minus e raised to minus 2t cube remain. Okay, now we have to expand this bracket. Why? Because we cannot take inside this Laplace until and unless the three we have to expand this. Okay, now expand by using a minus b bracket cube. What is a minus b bracket cube? By Pascal triangle you have to prepare, or at least for cubic, until cubic just remember these formulas. A cube minus 3a square b plus 3ab square minus b cube. These are the basic two formula, a plus b bracket square and a minus b, a plus b bracket cube. And for minus, just replace plus minus sign alternative. Okay, now what is a here? E raised to 2t becomes your a, and e raised to minus 2t becomes your b. Expand like this. Okay, what we get? A cube minus 3a square b plus 3a b square minus this b cube. Okay, now we have to use the indice basic formula for indices. If indice raised to indice is there, you have to multiply these two. E raised to 2t raised to 3 becomes e raised to 60. Rest of the terms as it is. Minus is there, 3 e raised to 2t raised to 2 e raised to 4t e raised to minus 2t as it is, plus 3 e raised to 2t as it is, e raised to minus 2t into 2 minus 4t, minus as it is e raised to minus 2t raised to cube or raised to 3 become 3 into 2 60. Okay, now again your property of indices, if base is same, you have to add these two indices. If base is 1 and indice raised to indice is there, you have to multiply. Okay, if base are 2 and they are same, then you have to add these above indices. Okay, 4t minus 2t, 2t, rest of the term as it is, 2t minus 4t minus 2t. This is as it is. Now it comes in our regular Laplace formula. Okay, e raised to formula, e raised to 80 or e raised to minus indice. Now e raised to 60, take Laplace inside to each term and take constant outside from each term, and by it as it is. E raised to 60 Laplace is 1 upon s, plus is there. If plus is there, you have to put minus sign. Minus 6, this number 6, minus 3 as it is constant, e raised to 1 upon s minus 2, plus 3 as it is, e raised to minus 2 till Laplace is, if it is minus there, just replace plus 2, this number s plus 2 minus 1 upon s plus 6. Okay, now this as it is 1 upon s minus 6 minus 3. Okay, just put these two terms first, because base is same s minus 6 in s plus 6, they are just opposite to each other. We can add these two first, and from these two just take 3 outside. Okay, what we get, this term becomes s plus 2, this positive term take first, minus this s minus 2. Okay, now cross multiply these two terms and these two terms. What we get, s plus 6 minus this terms becomes opposite, minus 6 minus minus plus 6 divided by s minus 6, s plus 6. And we know one formula, a plus b into a minus b is a square minus b square. That's why we do these two addition first. Okay, plus now this is 3 common, again cross multiply s minus 2, this is again minus s minus 2 upon s minus 2 into s plus 2, multiplication of this denominator. Okay, now s gets cancelled, s 6 plus 6 12, plus divided by denominator is a square minus b square, that is s square minus 6 square 36, plus 3 into this s gets cancelled, minus 2 minus 4, divided by this s square, a square minus b square, a plus b into a minus b is a square, that is s square minus 2 square, that is 4. Now again 4th is a 12, and 12 take outside from this numerator as 12 upon 8, it becomes outside 12 upon 8, and inside 1 upon a square plus minus 36, and this becomes minus 1 upon s square minus 4. Now again these are two very simplest terms, that's why cross multiply. We get s square minus 4 minus s square plus 36 divided by multiplication of these two terms. S square gets cancelled, 36 minus 4 is 32. Outside 3 by 2 as it is, 32 upon these two multiplication, and simplifying we get 48 upon s square minus 36 into s square plus minus 4. Okay, this is one homework, cos hyperbolic qt, like